Now we want to take these ideas to look at how we can graph a function by applying the different transformations, rather than, again, resulting to a table of values or something a little more long-winded. One thing that can be helpful is to take a given function and write it out in sort of a long form where every single one of our constants is being represented. For example, we could rewrite x cubed minus 3 as 1 times the quantity x minus 0 cubed minus 3. We don't need to take that step, but if it's helpful to help identify what the value for each of those constants are, and then let us know what we're doing in this case is taking that graph of x cubed and shifting it down by 3 units. To give ourselves sort of a placeholder, we could start off by graphing x cubed itself. So we'd have points at 0, 0, 1, 1, and 2, 8. Then negative 1, negative 1, and negative 2, negative 8. Applying that shift down of 3 units would take every single point and slide it down by exactly 3 units. So what we'd end up with would be a new curve passing through our new points. Which would look very similar to the graph we started off with, only translated or shifted down by 3 units. In example 2, we have g of x equals the square root of the opposite of x. This would be the same thing as saying g of negative x. So since we have that negative on the inside of that function, this means we want to reflect across the y-axis. So we could plot the square root function or sketch that out. At x equals 4, we would have 2, and at x equals 9, we would have 3. And then in order to reflect across the x-axis, we would just take each of those points and plot them equidistant on the other side of the y-axis. So again, understanding those transformations and reflections allows us to come up with the graph of a new function much more quickly than by going back to a table of values or having to plot points in a more long-form fashion. In example 3, if we want to again write this out in its long form, where we represent each of those constants, we see that the only constant that we have that's changed from its starting form is that value for a, which means we're going to have a vertical compression of 1/4. So if we start off by graphing x to the 4th, we would have our intercept at 0, points at 1, 1, and 1, negative 1. Since what we have is this vertical compression of 1/4 being applied, our function values that originally would have been at 1 and 1 will get compressed by a factor of 1/4, meaning we'll take those function values and multiply by 1/4. So instead, we'll be hitting the point 1, 1/4 and negative 1, 1/4. Meaning our graph is going to be opening wider than it was before, because those points are all being compressed down towards the x-axis. What we're mostly doing here is just sketching, so apart from a few points to kind of anchor our picture, we're not overly concerned with how accurate our graph is, but we want enough points to get the idea of what transformations are being applied. Graphing our function in example 4 is definitely going to benefit from a rewrite. The first thing we'll do is just reorder our terms here. So first we have the opposite of that quantity, x minus 2 to the 4th power, and then plus 3. Since we have this negative out in front of this x minus 2 to the 4th, what we want to do is actually factor that negative out completely from both terms so that we have the opposite of our entire function. So we're going to factor that negative out to rewrite this as the opposite of the quantity x minus 2 to the 4th minus 3. So in this case, our function is actually this interior function f of x, and then h of x is going to be the opposite of that interior function f of x, meaning we have a few different things happening here. Since we're taking the opposite of our function, that's going to be a reflection about the x-axis. We're going to be shifting to the right 2, and we're going to be shifting down 3. We're starting off with the graph of x to the 4th again, so we'd have points at 0, 0, 1, 1, and negative 1, 1. What's going to happen is each point is going to be shifted to the right by 2 units. So if we look at the origin, it's going to be shifted to the right by 2 units. It's going to slide down 3 units, and then it's going to be reflected across the x-axis. So we're going to go to the right 2, down 3, and then since we're reflecting about the x-axis, it will actually be 1, 2, 3 units above the x-axis. So this is our point that was 0, 0. Now we'll look at 1, 1. It's going to be shifted to the right 2 units, down 3 units. So it's 2 units below the x-axis. Reflecting about the x-axis will shift it to 2 units above. Plotting it right here. And then for our point negative 1, 1, we'll shift to the right 2 units and down 3. Reflecting about the x-axis, we'll put it at 2 units above the x-axis. To give us our new curve, or our new function, that is, again, shifted to the right by 2 units, down by 3, and then reflected across the x-axis.